4.4, Introduction to Related Rates. Let x and y be functions of time t such that the difference is a constant. Write an equation that describes the relationship between the rate of change of x with respect to time and the rate of change of y in respects to time. So first of all, we want to make a function that's a difference of x and y being a constant. So the difference of x and y, so that would be x minus, because difference means y minus, equals a constant. We'll call the constant c. All right, now we want to take the derivative of this in respect to time. So the derivative of the respect to time would be we're taking both, the derivative of the whole thing or both sides in respect to time. So the derivative of x is just going to be 1, or 1 dx dt. The derivative of y is going to be 1 dy dt, because again it's a chain rule here. And the derivative of c, of a constant, is just 0. All right, derivative of a constant is 0. Derivative of y is 1 dy dt because of the chain rule. And derivative of x is 1 dx dt because of chain rule. So that would be your derivative function, and we are done. Here's your rate of change of x in respect to time, and here's your derivative of y in respect to time according to what they're asking. Assume the area of a shape is calculated using the formula right here. A is the area of the shape, k is the length of a side that stays constant, x varies depending on the certain measurements. Write an equation that describes the relationship between the rate of change of A, which is area, with respect to time, and the rate of change of x in respect to time. So what we're going to do is we're going to take this equation right here and take its derivative in respect to time. First thing I want to do real quick is rewrite it. I just think it's a little bit easier in my mind to rewrite it as this. That, to me, makes it a little bit easier. And then we're going to take the derivative in respects to time. So the derivative of A in respects to time is just going to be dA dt. All right, next, the derivative of k is a constant. So let's just put that constant in front of the x to the negative second. So that would just be negative 2k x to the negative third times dx dt. Because again, this right here becomes negative 2x to the negative third, and the k times the 2 just kind of stays there because the k is like a constant, like 3x squared. It's kind of what it's saying. And then you take the derivative of x inside, which is dx dt. So this would be my equation for what they're asking for. Rate of change of A and the rate of change of x. And you could rewrite that as the following as well if you want to rewrite it to look like this. It could also be negative 2k over x to the third dx dt would also work perfectly fine.